All right, now we have our first video for section 2-3. This is elimination using addition. So elimination is another method of solving a system of equations in which the equations are added together to eliminate one variable. So for today's lesson, we're just going to go over elimination, taking our two equations and either adding them or subtracting them from each other. We won't necessarily go too deep into multiplying one or the other by some numbers, but in tomorrow's lessons or later on we will have to use multiplication a little bit, so that's kind of included in our steps here. The main steps when using elimination are, first step, write the system of equations so that like terms are aligned. And what that means is, again, we're moving around our equations so that we put x over x, we put y over y, we put our constant term over the constant term. So we're just lining up our equations. And again, you'll see what this looks like in our examples. For step 2, we determine whether the equations need to be multiplied by a constant so that the two equations can contain opposites. Now again, we're not going to do that so much in this video or this lesson, but that'll come more in play in our next lesson. We're going to have to multiply each equation by something to get them to equal each other. For step 3, then you add or subtract. Remember, adding and subtracting are in a sense kind of the same thing. You add or subtract the equations to eliminate one variable. So you'd put this equation over that equation, and you would add the equations together or subtract them, and that would get rid of all of the x's or all of the y's. Step 4 then, we're going to solve the equation that results from step 3 for the variable. So after we've added our equations together, and they used to have x and y, now they just have x, or maybe they just have y. So you solve for that and get x alone, or get y alone, and then whatever you get there, that is the x value or the y value for your solution. So you'd figure that part out already. Step 5, if you figured out x or you figured out y, you plug that into the other equation. You substitute that value from step 4 into either of the original equations. Then you solve for that equation to get the other variable. So again, you're plugging in x or y to get out the other one, y or x. Okay, and again, I'll show you what this looks like in our examples. So if we look at example 1, we're going to solve this system by elimination. So remember our steps here, we need to add up or line up the like terms, add the equations, solve for x or y, depending on which one, and then plug it in to find the other variable. Well, in this case, we already have 3x minus 7y equals negative 11, and it's already placed over 6x plus 7y equals 20. So in this case, as we look at it, here we have our x terms. Oh, I'm going to use that in blue. X terms are all lined up. Our y terms are all lined up. And our constant terms, I'm going to use C for constant, they are all lined up. Right in line there. Right in line, right in line, and right in line. Okay, that is our very first step, is just to make sure those are all lined up. And that one was already done for us, so we don't have to worry about that. Now that we have everything lined up, we just simply add the equations together. So we'll just put a plus sign there and see what comes out. If we add 3x and 6x, that's going to become 9x. If we add negative 7y, have to call it negative because it has that minus sign, negative 7y and positive 7y, that's going to be 0y, or just 0. And if we look at our constants again, negative 11 and positive 20, we add those together, we get 9. So that's where this new equation came from, right here. Using 9x plus 0 equals 9, well, we can kind of get rid of that 0. We don't need to say plus 0 on that, so we just have 9x equals 9. If we divide both sides by 9, this side and this side, we can see then that x has to be 1. So our solution in this case, we would be using x equals 1 as going to be part of our solution to this system. What do we do with that new information now that we know x equals 1? Well, we can plug it into one of our equations. So if I use this one as my original, instead of saying before we had Move some of this out of the way. We had 3 times x, then minus 7y equals negative 11. Well, I know now that x has to be 1, so I can just plug that in right here. So we'd say 3 times 1 minus 7y equals negative 11. So I wrote the 1 in purple so you can kind of see that it came from the x. Now that we multiply everything out and simplify it, 3 times 1 is going to be 3. And that's no longer, it's not an x term, it's a constant because it's just the 3. So that's written in green. We're subtracting 7y. Or in a sense, you can kind of think of it as we're adding negative 7y. So negative 7 times y. And that's all going to equal negative 11. And that, again, is a constant. Okay? Maybe I should show you. We're going to subtract 3 from both sides to get rid of that 3 constant. So that's how we get to negative 7y equals negative 14. To get rid of this negative 7, we're going to divide by negative 7. Divide by negative 7 on both sides of our equation. As long as you do it to both sides, then you haven't changed anything. So negative 7y and then divided by negative 7 just leaves y. Negative 14 divided by negative 7, well, 2 negatives dividing would make a positive, so we would have y equals 2. So in the end, our solution for this system is the point where x is 1 and y is 2. So this is our solution. If we were going to graph out those two equations, this is where they would intersect. This is the only spot where x is 1 and y is 2. That's the only spot where both of those equations have the same x and the same y values. So let's look at example number 2. We're going to solve the system by elimination again. So like before, we have to line up our like terms, add the equations, solve for x or y, and then plug in that x or y, plug in the variable to find the other variable. Well, in this case, we look at our two equations, and again, they're written right above each other, so our x's are lined up, our y's are lined up, and our constants are lined up. The only problem is, it looks like both of our x's have a 4, which is a good thing. It's nice that they're already kind of done for us right there, but both of them are negative, and we wanted a negative and a positive. We want them to be opposite of each other. So instead of adding the equations, I'm going to subtract them. Okay, I'm going to take the top equation, subtract the bottom one, because we know that if we're subtracting something, it's like adding the opposite version. So instead of saying minus a negative, I can say this is adding a positive version. So we're adding positive 4. Instead of saying minus positive 3, it's like I'm adding negative 3. Instead of saying I'm minusing negative 17, I'm actually adding positive 17. So I'm going to change that to a positive. This is a negative here. Okay, so now that I look at them, I can say negative 4x and then add on 4x. That's how I get to 0x, or just 0. Negative 10y, adding on negative 3y. Negative 10 plus negative 3 would be negative 13, so we'd be at negative 13y, because those are our y terms. Same thing, our constants, 22, and we're adding positive 17. That's going to put us at positive 39. So now our equation, again, we don't necessarily need this 0 anymore. It's just negative 13y equals 39. Looking at that equation, if I want y alone, I can divide both sides by negative 13. When I do that, that's going to give me simply y equals negative 3. So we got rid of the coefficient in front of y, and then divided 39 by negative 13. Negative, or positive divided by a negative would be negative. 39 divided by 13 is 3, so y equals negative 3. What do I do with that new information now? Again, this is where I take that and I plug that back into one of my original equations. So I can say instead of 4x plus 3y equals negative 17, I can do negative 4x plus 3 times negative 3 equals negative 17. So you can see I picked this equation. It would have been fine to pick the other one. We could have picked this equation as well. I just happened to pick the second one. It doesn't really matter. You're just plugging it into one of our original equations. From here, we just have to kind of simplify things out. 3 times negative 3 is going to be negative 9. So that first piece, that negative 4x, that's an x term, so we're going to write that one in blue. 3 times negative 3 is a constant now. It's no longer a y term because we don't have any y's. It's a constant, so it's just negative 9, and our negative 17 is still on the other side. So at this point, it looks like we need to move that negative 9 away from our x terms. So we're going to add 9 to both sides of the equation. When I do that, that's going to cross those pieces out. So we just have 4x, or negative 4x, should I say, on the left side. Negative 17, and then we're adding on 9 would put us up to negative 8. So now we have negative 4x equals negative 8. How do we get rid of that negative 4? Well, again, we're dividing our whole thing by negative 4. I suppose I could write it over here. I'm going to show you again. We're doing it to both sides of our equation. So negative 4x divided by that negative 4 is just going to leave x. Negative 8 divided by negative 4 is going to leave 2. So now we have x equals 2. So before we knew y has to be negative 3, now we know x has to be 2. So our solution then is the point, or the ordered pair, 2, negative 3. Again, if we graph those lines, this would be the spot where they intersect. Or this is the only ordered pair, this is the only set of x and y values that would be true in both of those equations. For this one, for whatever reason, the notes say solve by substitution. Go ahead and cross that out. Correct them. We are using elimination. We could use substitution here, but we're going to use elimination. Now in this case, we have 7x plus 10y equals negative 29, and that's over. For now, you can kind of think of it as the equation x plus y equals negative 5. Now why do they have the whole thing in parentheses and saying that it's multiplied by negative 10? Because what they're saying is we're taking negative 10, multiplying to both sides of the equation. We're multiplying the whole equation by negative 10, which is totally legal. We can do that as long as we multiply both sides by the same thing. It's like we didn't actually change it. So that actually would make it be, if we multiply that negative 10 by everything, again, it's kind of it's almost like a distributive thing. We distribute it to each part. So it would actually be 7x plus 10y equals negative 29 is our top one still. That didn't change. But the bottom one would actually be negative 10x plus negative 10y equals positive 50. Because again, over here we had to distribute that negative 10 to each piece. So now that we've distributed that, and we have our two equations here, again, it looks like we have our y's as opposites. We have positive 10y and a negative 10y. So when we add these two equations up, add them together, those ones will cancel out. So positive 7x plus negative 10x is going to leave negative 3x. 10y and negative 10y will come out to 0y, or just 0. And negative 29 plus positive 50 will be 21. So working our way down then, we kind of get rid of that 0 and just say negative 3x equals 21. So to get rid of that negative 3, we're going to divide both sides by negative 3. And I can write it over here. Again, just kind of help you remember, we're dividing both sides by the same number. It's actually really similar to this step, how we multiplied both sides by the same number. We multiplied by negative 10. Now I'm dividing by the same number. So it's occurring to both sides of the equal sign. As long as it's happening to both sides of the equal sign, you're not actually changing the equation. So you can multiply a whole equation by the same number at any time, and it's totally legal. When we divide by -3 then, that's going to leave our x alone, so it's just x equals -7. So at this point, we have solved for x. Now we're not quite done. Like before, we still have to plug that into one of our equations. So I'm going to plug it into the top equation. Again, I could have picked either one, but I happened to pick the top one this time. And wherever I see an x, I'm just going to say -7. So instead of 7x, it's 7 times -7. So we'll have to make sure we multiply that. Plus 10y equals -29. Okay, multiplying those pieces out and working them down, that 7 times -7 is now a constant term. So there's got no variables, that's why it's green. So it's -49 plus 10y, and that's a y term, that's why it's red, equals -29. Now, again, if we're trying to work towards getting y alone, we want to get rid of this constant term on this side, so we have to add 49 to both sides. I suppose I can write it over here too. Right? Add 49 to both sides. When I do that, that leaves me with positive 10y, or just 10y, equals positive 20. -29, add 49 would get us to 20. To get y alone then, we need to divide both sides by 10. When you divide both sides by 10, that's just going to leave you with y equals 2. So at this point again, we have our y value, we have our x value. Move this aside. So we'd say our solution is the point -7, 2. This is the only spot where both of those lines will cross through. Okay, and both equations will have a spot or a point on there where x is -7 and y is 2. All right, we have another example here. We're looking at solving with elimination. So again, we were given this this equation inside the parentheses being multiplied by this piece on the outside, and we're asked to kind of solve that piece out. When we do that, again, we kind of have to distribute each piece. So the top one stays as 6x plus -15y equals -6. And again, I saw this negative or this minus here, and I just broke it up into adding -15y. So that's why mine looks a little bit different from theirs. When I write it out as 6x plus -15y equals -6, then I have to put it over the other equation. 3 times -2x becomes -6x. 3 times 5y becomes positive 15y. And 3 times 2, that constant at the end, would be 6. Okay, so now I have my two equations written one over the other, and I add them together, and unfortunately I'm just going to get a bunch of zeros. 6x minus 6x is 0, -15y add 15y is 0, and -6 add positive 6 is just 0. In this case, or in a case similar to this, if you can just solve them out and you get nothing but zeros. Let's think about if I took this whole equation and I multiplied it by -1. Okay, essentially I'm just switching the signs. This piece here would become 6x. This piece here would become -15y. This piece here would become -6. 6x plus -15y equals -6. What it's saying is these are all the same equation. When we can solve out and get 0 equals 0, that means your system is showing all the same equation. So 0 equals 0 means it's a consistent dependent system. Remember, that means there is a solution. It's an infinite solution. We're on the same line. Okay, so our solution is every single point. If we were to solve this out and you got 0 equals some number, so if we got these two to be 0 and this thing came out to some number like 7, or maybe it came out to 13. So 0 equals 13. In a case like that, that means you have an inconsistent system. That one's going to show parallel lines. Okay? If we're working with elimination and we get to a spot where we have 0 equals some number, you can just know from there there's no solution because they are parallel lines. It's an inconsistent system. Okay? So in this case, because we have 0 equals 0, our solution is an inconsistent, or should I say a consistent dependent system. Every single point is the exact same. All right, we have our last example then. For example 5, it asks us to find the numbers described in this situation. And it says two numbers added together equals 14, and their difference is 8. So step 1, we need to write a system for that, and then step 2, we need to solve it. So for my two numbers, I'm just going to call them x and y, and I know when I add x and y, I get 14. So x plus y equals 14. This word difference means subtraction, so when I subtract them, I get 8. So x minus y equals 8. That would be my system that I'm trying to solve here. Now, normally I might need to work my way through and maybe do some substitution or maybe work with multiplying things around, but this one is already written so that I have y and y, one being positive, one being negative. So I can just add my equations together. Suppose I can put the add right here. X plus x is 2x. Positive y plus negative y is 0y, or just 0. 14 plus 8 is 22. So I have the equation 2x equals 22. To get rid of that 2, I'm just going to divide it from both sides of my equation. 2x divided by 2 is just x. 22 divided by 2 is 11. So x equals 11. That's one of our numbers. We need to find the other number, though, so we need to make sure we plug that into one of our original equations. So I'm going to plug it into that first one. Instead of saying x plus y equals 14, over here I'm calling it 11, because I know x has to be 11. So 11 plus y equals 14. And down here I just rewrote it, and again I called that 11. It's a constant, so I'm going to write it in green, plus y, that's our only y term, or just one y. I will write that one in red because it's, again, a y term. I'm trying to get that alone, equals the constant 14. There's no variables connected with that. How do we get rid of that constant 11 on both sides? I need to subtract 11 from both sides of the equation, which is going to leave us with y equals 3. So the two numbers in this case are 11 and 3. Those are the two numbers such that when you add them together, you'll get 14. When you subtract them, you get 8.